All right, as you can see, we're going to be working on arithmetic sequences. And basically, an arithmetic sequence is a sequence where you have what we consider to be a common difference. Meaning, if you go from one term to the next, you're going to be constantly going by the same amount. So you can see starting at 6, going to 8, we would add 2. And from 8 to 10, we would also add 2. And then from 10 to 12, we would add 2. So that kind of verifies that this is, in fact, an arithmetic sequence. Now, what we're going to do with it is we're going to see how we can write this in order to be able to figure out what any of the terms are. Okay, so one way that we can do this is called an explicit method. And what we're going to do is we're going to be able to find the term. Okay, and that's how we identify the term we're looking for. That's a sub n. N is going to be the number of the term. And the way that we're going to be able to find that is we're going to take whatever the first term is, and we'll write this a little neater in a minute. Okay, so we're going to take the first term and we're going to add to it whatever the common difference is. In this case, the difference is 2 times 1 less than the number of the term we're looking for. And what I mean by that is 1 less than the number of the term we're looking for is that's going to be n minus 1. So if we're looking for the 8th term, okay, to find the 8th term, okay, this is going to be the first term, which in this case is a 6, plus 2 times the number of the term, which again, this is going to be 8, minus 1. So in order to find what the 8th term is, we're going to have 6 plus 2 times 7. Now, the reason that this piece over here has to be 1 less than the number of the term that you're looking for is because the one term that we're taking away there, we already have here. That's the first term. So if we had left this just as the 8th term, we would have had 2 times 8 terms plus one more term, which would have been the 9th term. That's the reason that this piece over here has to be n minus 1. Okay, so in this case, you could see that the 8th term is going to be equal to 6 plus 14. It would be a 20. And sure enough, if we were to extend the sequence out, we would find that the 8th term is going to be a 20. Okay, so let's try another example. Let's see how this works out. For this example, you could see that our common difference here, that we're going to be taking away 3. We'll be subtracting 3 and subtracting 3. So again, we're going to write our basic form is going to be this, and then it's going to be our first term plus whatever that common difference is, and then 1 less than the term we're looking for. So again, let's say in this case, just to make it so you can kind of see how it works, let's say we're looking for the 4th term. I know that we can see it, but let's say we're looking for the 4th term. So that's going to be the first term plus the common difference is negative 3 times 4 minus 1. So our 4th term is going to be 4 plus negative 3 times 3. So our 4th term is going to be 4 plus negative 9. So that means that our 4th term will be negative 5, which in this case, clearly you can see the 4th term is negative 5. So this is the method that we use in order to be able to find a term. And again, this is called explicit. There's a recursive method we'll talk about in another video, but the explicit method to me seems like it's pretty straightforward. It makes a lot of sense if you break the pieces down and see it. And just so you know, if you see this written out, sometimes you'll see it written technically. It'll kind of look like this when we're looking for the arithmetic sequence. You'll see something that looks like this, and your a sub n. And to indicate that the sequence just keeps going from the first term, n equals 1, through infinity. That means forever. It'll just keep going on forever. Okay. Again, that's not really the important part of this. The important part is knowing how to find the missing term, which is what we covered on the first two examples.